Today we are going to discuss the topic about speed control of induction motor. The speed control of induction motor has two different tasks. One is stator side control and another one is rotor side control. The stator side control is stator voltage control, stator frequency control, voltage frequency control, pole changing method. And rotor side control is adding external resistance, cascaded control and slip power recovery scheme. The three-phase induction motor basically constant speed motor. It is widely used for low cost and rugged construction. The speed control of induction motor done the cost of decreases in efficiency of low electrical power factor. Requirement of speed control. Speed control means that change the drive speeds as desired a process of maintain different process parameter at different load. Energy saving. Speed control is different concept from a speed regulation where there is natural change in speed due to change in the load on the shaft. Speed control either done manually by an operator or means some automatic control device. Low speed starting requirement. Then methods of speed control. Already discussed stator voltage control and stator frequency control and stator current control and V by F control. Stator voltage control. The speed of induction motor can be controlled by varying the stator voltage. This method is known as stator voltage control. Supply frequency of constant. It has two different methods. One is using auto transformer and another one is primary resistor connected with the stator winding. The synchronous speed of the ns equal to 120 f divided by b and slip is ns minus n divided by ns. Torque equal to t is equal to 3 divided by 2 pi ns into E2 square or 2 into R2 square plus X2 square. The curve drawn between torque and speed. The V initially increasing, after that decreasing. The torque is proportional to the stator voltage, that is torque directly proportional to applied voltage. In this method used for the wide range of speed control. Frequency control. The stator frequency control is the one of the method of speed control of three-phase induction motor. Frequency. Now the formula is ns equal to 120 f divided by p. F equal to frequency of supply voltage and P is equal to number of poles. Synchronous speed of the motor is directly proportional to the frequency of the supply voltage. When the supply frequency changes, motor speed also changes. V is equal to 2 pi f T1 pi kW. Pi is the flag and kW is the winding factor. F is the frequency stator. T1 is the number of turns. The prime mover is connected to the AC generator. The AC generator is connected to the three-phase induction motor. It's considered as two cases. One is low frequency operation and another one is higher frequency operation at constant voltage. Low frequency operation at constant voltage. Low frequency operation, first supply frequency is decreases the constant voltage and air gap flux increases. Low frequency operation following effect. The reactance will be low, more losses, very low efficiency. High frequency operation at constant voltage. V constant, frequency increases and flux will be decreases. By increasing the supply frequency of the motor following effect, the no load speed is increases, maximum torque are decreasing and starting torque is reduced. Stator current control. The stator current control is Starting torque of induction motor proportional to the square of the stator current. It is independent of supply frequency. It is independent of rotor resistance. Now torque maximum is equal to 3xm ISC divided by omega synchronous speed the whole square, or omega m divided by rr square plus omega m xm divided by omega synchronous speed. The circuit diagram is given. First, AC line is connected to the input rectifier, and input rectifier connected to the DC bus. The DC bus connected to the three-phase induction motor. It is also known as voltage frequency control, and the increasing the frequency, air gap flux changes. This will lead saturation of the motor. To avoid this, air gap flux should be maintained constant. To maintain the air gap flux at constant, the parameter V and must be changed so that maintain V by F ratio constant. It is called V by F control. Then the DC supply is fed from inverter circuit. It converts DC into AC, voltage variable frequency. This output is fed to the stator of induction motor by varying the V and F, maintaining V by F ratio constant so that induction motors be changed. It is only applicable for below base speed. Indicates for voltage and rated frequency that V by F constant. 2 indicates reduced voltage and reduced frequency maintain V by F ratio constant. It is most powerful method of induction motor. Stator rotor resistance control. The stator control is used for wound motor of induction motor. The constant frequency of synchronous speed of the motor inversely proportional to the number of poles, ns equal to 1 divided by p. By changing the poles of the motor, synchronous speed can be varied. Changing the number of poles has been incorporated at manufacturing state at such as machines called pole changing motors. This is the curve of torque and speed curve of the induction motor. First x-axis is rotor speed and y-axis is current at full load. Advantages of AC drives. The AC drives is same rating, lighter weights compared to DC drives. An AC drive requires low maintenance. AC drive less expensive. Provides more efficient means of motor speed control. Reduce the thermal and mechanical stresses on the motor. Provide low speed motor starting facilities. Save more energy. Thank you.